The James Webb Space Telescope, additionally known as Webb or JWST, is a logical pioneer that has uncovered astounding insights regarding stars, planets, systems, and other captivating grandiose peculiarities, as well as setting new principles for logical energy. Webb is hailed as the revered Hubble Space Telescope substitution. People from one side of the planet to the other are trading photographs or utilizing crude information to make new experiences. 1 year has passed since the impressive James Webb Space Telescope uncovered its first-ever memorable picture of the universe, stunning cosmologists all over the world with its unprecedented detail. However, its latest finding is a sickening image of the universe that we have never seen before. What has been found heretofore by the James Webb Space Telescope? Is it suggesting more conversation starters than it deals with any consequences regarding researchers? Go along with us as we investigate how the James Webb Space Telescope catches the most unnerving picture of all time found in history. The successor to the Hubble telescope revealed new data about star development, cosmic system consolidates, and the early universe just 1 month after the introductory photographs were delivered. The pictures were amazing, uncovering the universe exhaustively. From that point forward, the quantity of revelations has soared, furnishing researchers with a tremendous information mother lode. James Webb Space Telescope perceptions of infinite tarantulas, record-breaking space smoke, stars' nearly cosmic explosion, exploblasts, and other mind-boggling divine objects have been reported. This satellite observatory's cutting-edge innovation permits us to peer farther into space than before, revealing previously obscure insights regarding the universe. Another time in cosmology has unfolded, thanks to the photographs, which can be so nitty-gritty. As a method for remembering the first year of the James Webb Space Telescope's activity, NASA delivered a picture that shows a minuscule star-forming region in the Line-Iuki cloud complex. The picture shows planes ejecting from infant stars as infinite residue billows of different colors. Impact subatomic hydrogen makes up the red residue, and the presence of a circumstellar circle causes some qualms about a few stars, suggesting the chance of planet development in the far-off past. The picture might show grandiose commotion. However, as per NASA, this heavenly nursery is small and serene contrasted with others. Furthermore, many of the youthful stars in this region are about the size of our Sun or even considerably more modest, making it the closest star-forming area to Earth. This image was caught by the fundamental camera of the observatory, the Webb Space Telescope's near-infrared camera, which catches enormous pictures in 2 particular infrared ranges at the same time. Moreover, the Space Telescope has worked on our insight into exoplanets or universes that circle stars other than our Sun. James Webb is especially great at taking a gander at huge V universes. The satellite observatory found its first exoplanet, LHS 475b, toward the start of 2023. The planet is 41 light-years far off and has a width equivalent to Earth, agreeing to NASA. James Webb is the sole functional telescope able to do arranging the air of Earth-sized exoplanets. After that, the James Webb Telescope found verification of long-one worlds that from a hypothetical stance shouldn't have existed. Eva Swinburne College and his worldwide cosmic group have viewed as 6 colossal old cosmic systems called section breakers. They can possibly completely have an impact on the manner in which we ponder space. These gigantic universes might have appeared between 500 to 700 million years after the huge explosion. As per the scientists' results, recently the telescope's infrared sensors distinguished them through the utilization of these instruments, permitting us to look back in time around 13.5 billion years when stars and cosmic systems were a lot more established. The colossal huge of the universe breakers has left researchers dumbfounded. Systems in the early universe ought to have been 10 to 100 times less than that. Their estimations demonstrate that these 6 articles might be billions of times heavier than our Sun. The amount of all the stars in one cosmic system may be 100 billion times heavier than our Sun. Does the prospect of attempting to grasp something so huge make you feel uncomfortable? Despite the fact that most of universes during this period are generally minuscule and just growing very somewhat, a few beasts arrive at adulthood undeniably more rapidly than others. It clearly would cause this or the way in which it would work. Penn State College cosmology and astronomy Wright assistant teacher and study co-creator Joel Lader communicated his amazement at the revelation of another classification of objects framed at the huge explosion. The revelation that the improvement of colossal universes started at the absolute beginning of the universe's set of experiences difficulties a significant number of our previously held convictions about the condition of science. It appears our discovery is so strange that it presents difficulties to the logical community. It tosses into uncertainty the whole situation of how worlds shaped in the early universe. Way more enormous than anybody expected, it portrays the things all universes in the reach are considered children since they are still during the time-spent arrangement. However, systems that are basically as old as our own have been found in the early universe, which was recently remembered to its start. Spectrometry, which isolates light into its part frequencies to empower more exact distance estimations, is still expected to approve the outcomes, which have researchers scratching their heads. There are just a small bunch of as-of-late found objects for which distance and mass have been confirmed. Assuming the information is precise, system creation needed to have been significantly more productive and quick than what is presently suspected. The reality that spectra supported our norm working frameworks-based inductions from the visuals is promising. For quite a long time, researchers have tried to translate inestimable history. In any case, a solitary piece of hardware might hold the key. Perceptions of reality have long piqued the interest of researchers, so it isn't really to be expected that clashing realities introduced by telescopes could prompt a presently absence of clearness. Cosmologist Dr. Katie Mack has decided to offer her bits of knowledge into the Make a Difference to make sense of how this could be happening. She drawn out the way that the JWST has been giving proof of cosmic systems that appear to have started or developed a lot sooner than what researchers had expected from their models. Don't stress. However, as Mack brought up, the telescope is catching pictures of worlds more than 13 billion light-years away, and they are somewhat foggy. It seems like there hasn't even been sufficient time since the huge explosion for these large worlds to have shaped by the dates that cosmologists have been getting from the telescope. Many in the field stressed on different hypotheses, including dim matter and the enormous detonation. However, we ought to go further into the proof to find out without a doubt. The telescope catches stunning perspectives on close nebulae, however, fluffy little spots with regards to faraway universes. The explanation is that various varieties are impacted by various pieces of the light range. The Webb telescope can identify light from a source in two unique ways. It might use a range by fanning out the light with a spectrograph, which works a bit like a crystal and inspecting the splendor of each tone, or it can utilize channels that block everything except a select scope of varieties. They can then work out the red shift of the universe by contrasting this information with spectra anticipated for systems with similar attributes. What this red shift illuminates us is the exact moment in astronomical history that we are seeing. Incidentally, numerous universes have an abundance of stars or stars that were too youthful when they would have lived by examinations of model spectra. There are a number of potential clarifications for this. The photometric readings could have been off due to issues with the telescope's adjustment. Then again, they might have been noticing a group of universes that isn't representative of the standard, or very small areas of the sky. Another conceivable clarification is that world range models are planned for closer worlds, which don't work well with systems further away. On the other hand, cosmologists would confront the exciting possibility of having to completely reconsider vast advancement if those universes are, without a doubt, incredibly huge and prior assessments were wrong. Yet, it's not really the main region where researchers have missed the mark. In spite of mechanical advancement, planets that are entirely huge to exist have specialists exceptionally astounded, and none more so than the finding of a planet that is considered too gigantic for itself. This has incited a reassessment of our system comprehension of planet creation and nearby planet group design, as well as the models created by cosmologists. In the fallout, a planet that is multiple times as immense as Earth has been seen. According to research out of Penn State, legend has it that this planet is in a planetary framework around the ultracool star LHS 354, a star that is multiple times less monstrous than our Sun. Before, as of late, seeing it for themselves, researchers didn't fully accept such a situation was possible. Yet, new proof shows that the biggest planet in our planetary group is truly circling one of the universe's littlest and coolest stars. An ultracool predominate.